Good morning, good afternoon, good evening. Welcome to this presentation on how to create C.U.T.E, domain-specific did, grammars, and parsers. My name is Michael Herman. I'm an independent blockchain architect, and I'm based in Alberta, Canada, and I live on a cattle ranch. Our snow is almost gone, but that just means it gets a little more messy here. I work about 10 hours a day on blockchain projects. The purpose of this presentation is to announce and show the reference implementation for the did-uri-spec grammar defined using ABNF notation, and then to demonstrate how to use this baseline grammar to create what are called C.U.T.E, domain-specific did grammars and parsers. The audience for this presentation is implementers and maintainers of parser software that is compliant with the did-uri-spec, including but not limited to people working with the W3C Identifier specification, did resolvers, anybody performing did resolution, agent-to-agent communication services, for example, in the Hyperledger Indy Agent framework. What is a C.U.T.E did grammar? Well, C.U.T.E is an acronym, and a C.U.T.E did grammar is a did-uri-spec compliant grammar that is concise, understandable, and technically elegant. And when we see the grammar, I hope you agree. A C.U.T.E did grammar is a did-uri-spec grammar that is easy to extend for an infinite number of different applications by being able to easily create domain-specific did grammars, and then to automatically generate compliant parsers in Java, C++, or C#. A DSDG limits the number of transformer options that are required or allowed for a particular application domain. The generic or baseline C.U.T.E did grammar, as well as any of the domain-specific did grammars derived from the C.U.T.E did grammar, are verifiably compliant with the did-uri-spec specification, as well as our FC 3986. The C.U.T.E did grammar approach for creating domain-specific did grammars is a perfect example of the open to innovation principle, where internet protocols and standards not only need to be open, but more importantly, open to innovation. The structure of the grammar, which you'll see in a moment, allows infinite extensibility for an infinite number of application domains. The concept of being open to innovation is the result of results from a conversation that Sam Curran had talking to a small group of developers, a side conversation at the BC Tech Summit Hyperledger Indy Bootcamp, about the importance over the course of history for internet protocols not only to be open, but more importantly, open to innovation. Innovations that might succeed and innovations that might fail. More specifically, Sam talked about that if you look at important internet protocols like TCP/IP that enable packets on the network to carry any type of data, including text, email messages, web pages, etc., and then subsequently streaming audio and streaming video, who could have ever imagined being able to carry those payloads on that original TCP/IP specification? It is vitally important for internet protocols not only to be open, but open to innovation. Innovations that might succeed as innovations that might fail. No one can foretell how specifications like the ones we're creating today will be used in the future. That previous article is from my blog on hyperonomy.com. So is this article called Giving Grammars Written with ABNF Notation the Respect That They Deserve. These articles are also in the presentation that introduces the concept of the did-uri-spec grammar and the whole development process there. So I won't belabor this too much. But the important thing really was one around language. And so I coined these the ABNF principles, and I'm just going to emphasize this slide. ABNF is a specification for a notation for describing grammars. ABNF notation is the notation described in that spec, in that ABNF spec for describing a grammar. A grammar is a description of the allowable linguistic constructs permitted in a particular language, the language you're trying to describe with the ABNF notation. RFC 4234-4 is the formal specification for ABNF notation. A grammar expressed using ABNF notation is intended to be executable. It's intended to perform the parsing function and to some extent the semantic analysis functions. Those were described previously in the did-uri-spec webcast. A grammar expressed using ABNF notation is the source code for a program. It's a source code for a program that can be read, interpreted, compiled, or executed by a human, by an interpreter, by a compiler or a virtual machine, respectively, in a way that conforms to the ABNF formal specification. So we leverage this very, very specifically, both the ABNF principles and the wording and the language here, as well as the open to innovation principle. There are some best practices for developing grammars written using ABNF. You can come back and view those on your own. And this is the did-uri-spec grammar. I guess the first time it's been kind of shown publicly. We also kind of refer to it kind of by its brand name, the C.U.T.E did grammar. And C.U.T.E stands for concise, understandable, and technically elegant. And we can see that we have a very clean grammar here. The second sort of paragraph of ABNF rules says that a did-uri there is a did, defined above, optionally followed by a transform, optionally followed by a path, optional followed by a query string, and optionally followed by a fragment. Very clean, simple definition of what a did-uri is. And then the more interesting thing is, what's a transform? Well, a transform starts with the pipe character followed by one or more transformers, and the transformers themselves are separated by ampersands. A transformer is either just a name or it's a name value pair. If it's a name, it's a $sign preceded by the name of the transformer option, preceding the name of the transformer option. If it's a name value pair, it's $sign followed by the name of the transformer option, equals sign, and then the value in double quotes. Now, I'll talk a little bit more about the rest of the construction there. It may seem like there's a couple of extra levels. At the very bottom, we can see that there's a rule called transformer options, and in the default grammar, the generic grammar as we call it, the generic did-uri-spec grammar, the only values in terms of transformer options is the generic option, any character string starting with the letter. And we can see that highlighted here. So here we are on slide 45 from the did-uri-spec previous webcast. Up here at the top, we have the standard 3 did-uri patterns for working with did documents, did document fragments, and remap service endpoint URI URLs. So what if we wanted to build a domain-specific grammar for did docs that only supported these 3 constructions? What would that look like? Here it is. So the top is completely identical to the generic C.U.T.E did grammar, to the generic did-uri-spec grammar. But at the bottom here, you notice that we've specified specific transformer options. We've specified select ID, the select ID option, and the service ID option. And optionally, we've left the generic option there, but if you want it to be really strong and say I only want select ID and I only want service ID, and if there's anything else you want the parser to fail, you could remove that / generic option at the bottom. This is where the cuteness of the did grammar kicks in. The fact that it's concise, understandable, and technologically excellent. So here is slide 45 again, but this time we're going to look at the service agent, feature protocol descriptions. So this is out of the, I guess it's called the protocol discovery hype now. And there's two formats. In 6, it says, give me all the feature protocol descriptions. And in the bottom one, it says, or number 7 rather, only give me the service agent feature protocol descriptions that match this pattern. And you can go look in the hype to understand that a little bit more. So what does it look like? Pretty simple. It only supports one transformer option, and that's called filter. Again, we have generic -option in there just to catch anything else. If your domain-specific grammar is going to be sort of flexible and fluid, but if you want to have a tightly spec'd domain-specific grammar, then you could remove generic option from the transformer options at the bottom. Just for completeness, this is slide 46 and just reminds you of some of the other patterns, and perhaps as the number of domain-specific did grammars increases, we'll add some more examples from here. Okay, so once you have the grammar, any of those 3 examples, the generic one, the did-doc one, or the Indy Agent feature protocol descriptions, then you need a parser. And so the parse2.com parser called aparse will read those ABNF specifications and produce Java, C# or C++ classes. It'll build parse trees for you. It's free to download, etc., etc. It's an amazing tool. It's also used by the folks over on the Universal Did Resolver project. After you create your grammar, or in the sense of just using any of those examples here, the creation of the grammar, you can just create it in Notepad or VS Code. It's just simply adding a few lines there. Then you can test it here. So on the bottom left-hand corner, you would open up your ABNF file. You would choose the symbol. In this case, the symbol you would use would be did-uri and not URL. This is a leftover from the previous grammar specification. And then you want to test, this did colon XYZ colon 1, 2, 3, 4. And at the bottom, you click results. The web page refreshes, and it'll tell you whether your grammar conforms with your test case. So wrapping up, we've been able to demonstrate that starting with the did-uri-spec, baseline grammar, the generic grammar that's RFC 3986 compliant, and able to recognize any did-uri, that we can create domain-specific did grammars, in this case on the left, one for did-doc, that understands the select ID and the service ID option as described above, and the ability to create, for example, the protocol discovery domain-specific did grammar that could be used within the Indy A2A communications protocol. Wrapping up, the same next steps as for the grammar itself. Continue to grow and validate the number of higher level did user scenarios, and by implication the number of lower level did URI use cases. Build and test the did URI grammar, as well as all the domain specific did grammars you're going to create. and then continue to grow the outreach in terms of awareness, knowledge, and understanding of the did-uri-spec specification amongst a diverse range of communities, and also a diverse range of did user scenarios. So again, my name is Michael Herman. I'm an independent blockchain architect. My email address is there, mwherman@parallelspace.net. You can usually find me on the Hyperledger Indy Rocket chat channels, or just flip me an email. I look forward to for hearing back from people. I'm interested in what domain-specific did grammars do you want to create outside of the traditional, did document context. This is a powerful, flexible, easy-to-use tool now, and I look forward to some really innovative and creative applications of it. Thank you.